Everyone thinks electric cars are about saving the planet, but the real reason they'll take over has almost nothing to do with the climate. It's about something much more fundamental: superior technology. Stick around to find out why. Right now, we're looking at electric cars as an emerging technology. They're like the first generation smartphones, impressive, but still finding their footing. But what we're witnessing is just the beginning. The electric vehicle is still an infant technology, and when it finally matures, it won't just compete with gasoline cars, it will make them completely obsolete. The entire automotive world is on the brink of a massive, permanent shift, and it's happening faster than most people realize. So, where does this revolution begin? It starts with the heart of the EV, the battery. For years, lithium-ion has been the standard, but the next leap forward is already here, and it's called the solid-state battery. This isn't just a minor improvement, it's a complete game changer. Labs are already developing solid-state batteries with a power density of up to 1 megawatt per kilogram. Now, that sounds like a lot of technical jargon, so what does it actually mean? It means a battery that can discharge an incredible amount of energy incredibly quickly. Imagine charging your car from empty to full in the time it takes to grab a cup of coffee. Imagine a range of over 1,000 miles on a single charge. And imagine acceleration that pushes you back in your seat like a supercar. That's the promise of solid-state technology. It solves the biggest pain points of current EVs, range anxiety and charging time, in one fell swoop. This isn't science fiction, it's the very near future of transportation. Of course, I know what you're thinking. That sounds great, but it must be incredibly expensive. And right now, you'd be correct. The initial cost of producing these advanced batteries is high. But this isn't because the materials are impossibly rare or the process is magic. It's because of a simple economic principle: economies of scale. Right now, production is limited. Factories are being built, supply chains are being established. The fixed costs, the research, the machinery, the facilities are spread across a relatively small number of units, making each one expensive. But think about any other major technology. Flat-screen TVs, computers, smartphones. They all started as luxury items, prohibitively expensive for the average person. Then, as production ramped up, as factories became more efficient, and as competition entered the market, the prices plummeted. The exact same thing is happening with EV batteries. We haven't reached critical mass yet, but once we do, the cost per unit will drop dramatically. We're on the steep part of the cost reduction curve, and once these technologies are produced at the scale of millions, electric cars won't just be competitive with gasoline cars, they'll be significantly cheaper to buy. Let's move on from the battery and talk about the motor itself. This is another area where EVs have a fundamental, insurmountable advantage. An internal combustion engine is a controlled explosion. It's hot, it's violent, and it's incredibly inefficient. In a typical gasoline car, only about 20 to 30% of the energy from the fuel is actually used to move the car forward. The rest, it's lost, primarily as waste heat. It's why your car has a massive radiator and cooling system. An electric motor, on the other hand, is a marvel of efficiency. It typically converts over 90% of the electrical energy from the battery directly into rotational force at the wheels. Think about that. Double, triple, sometimes even quadruple the efficiency. This means less energy is wasted, which directly translates to greater range from the same amount of stored energy. It also means the system is under far less stress. There's less heat to manage, fewer vibrations, and a smoother delivery of power. It's not an incremental improvement, it's a different class of engineering altogether. It's simply a better way to turn energy into motion. This leads us directly to the fourth major advantage: mechanical simplicity. A gasoline-powered car is a breathtakingly complex piece of machinery. The engine alone has hundreds of moving parts: pistons, valves, camshafts, crankshafts, all working in a precise, violent symphony. Then you have the transmission, the clutch, the exhaust system, the fuel injectors, the spark plugs, the oil pump. The list goes on and on. All of these are points of failure. They wear out, they need regular maintenance, and they are expensive to replace. An electric vehicle throws almost all of that complexity out the window. The drivetrain consists of the battery, a controller, and one or more electric motors. That's essentially it. There are drastically fewer moving parts. There are no oil changes. There's no complex multi-speed gearbox. There's no exhaust system to rust out. This profound simplicity results in two huge benefits for the owner: significantly lower maintenance costs and far greater long-term reliability. The car just works. It's a sealed system that requires a fraction of the upkeep of its combustion engine counterpart. This isn't just convenient, it fundamentally changes the cost of owning a vehicle over its lifespan. Beyond the core mechanics, the very nature of an electric platform opens up a world of possibilities that are simply impossible for traditional cars. Think about your smartphone. You buy it once, but it gets better over time through software updates. EVs are the same. They are essentially computers on wheels. Automakers can push over-the-air updates that improve efficiency, add new features, or even increase horsepower, all while the car is sitting in your driveway. This ability to evolve post-purchase is a paradigm shift. Furthermore, the architecture is inherently scalable and modular. The battery pack, for instance, can be designed to be replaceable or upgradable. As battery technology improves, you might not need to buy a whole new car to get better range. You could simply swap in a new, more advanced battery pack. This extends the useful life of the vehicle and protects your investment. And then there's the elephant in the room, autonomous driving. Building self-driving capabilities on top of a gasoline car's complex mechanical systems is a huge challenge. You have to electronically control a throttle, a transmission, brakes, and steering that were designed for human input. An EV, however, is electric from the ground up. Its acceleration, braking, and steering are already controlled by wire. This makes it a much cleaner, simpler, and more reliable platform for integrating the sensors and computers required for full autonomy. The EV isn't just a better car, it's a better foundation for the future of all transportation. So, let's bring it all together. While the environmental benefits are important, they aren't the primary driver of this shift. The real story is one of technological superiority. We have next-generation solid-state batteries on the horizon, offering incredible range and fast charging. We have electric motors that are vastly more efficient than any combustion engine. And we have a mechanically simple, software-defined platform that's cheaper to maintain, more reliable, and perfectly suited for an autonomous future.
Electric cars aren't just a greener alternative, they are a better technology. And the crazy part is, they're just getting started. The EV of today is the worst EV you'll ever own because the innovation is accelerating so quickly. So my question to you is, do you think EVs will dominate sooner than people expect, or is there still a hurdle we're underestimating? Comment below. I'd love to hear your thoughts. Thanks for listening.